All right, hello guys. Welcome to your first flipped video of the year. So what I want you to do is open up your journal, and in the on your first page that you want to start taking notes on, if you will please label this. It's really important that you label each of your pages so that you know when referring back to them what is going to be on the page and subsequent pages. So this is 1-1, Chapter 1, Section 1, and it is titled Variables and Expressions. Okay, so let's get started and see what we have for us. First thing we're going to have are some vocab words. So I need you to write down the word, and then we're going to follow it with our definition. So the first word is what a variable is. We're going to be using variables every day in algebra, so we need to know what that means when we say the word. A variable is simply a letter or a symbol that is used to represent a value that can change. So for example, X is a variable, okay? T is a variable. Any letter or symbol. We can use the symbol smiley face to represent a number that can change. In one problem, the smiley face can be a 3, whereas in the next problem, completely different problem, a smiley face can represent a -10. So our letters or our symbols are used to represent things, to represent values that can change. And X is not always going to be a 4. It's going to be different things in different problems. The next word is a constant. Now a constant is different because a constant is something that does not change. A 4 is always a 4. A 0 is always a 0. -100 is always -100. It can't ever change to be anything else. So a constant is simply a value that does not, cannot, will not change. A numerical expression now. We have two different things here, numerical expressions and algebraic expressions. A numerical expression is an expression that may contain only constants. Those are things that cannot change, values that don't change, so numbers, and operations. Operations are addition, subtraction, multiplication, and division. Okay, so you can have numbers and you can have operations. An example for you, 12 plus 4, that's a numerical expression. -10 times 10, numerical expression. It has numbers and it involves adding, subtracting, multiplying, and dividing. Okay? The next word is an algebraic expression. In algebra, we add variables to things. Okay? So an algebraic expression has variables, constants, and operations. What's the only thing that it has that a numerical doesn't is that you're allowed to now use variables. So instead of 12 plus 4, I could write x plus 4. Instead of -10 times 10, I could say -10 times y divided by x. Okay, so it's involving numbers, variables, and your 4 operations. An expression is simply something that does not have an equal sign. So you'll notice in all the examples I've given so far, we haven't put an equal sign in anything yet. That's what we call an equation. So what I want you guys to do right now is reflect on what some of those vocab words we just went over. You're going to create a double bubble map. On the left side, you're going to have a numerical expression. So I want you to list the characteristics of what a numerical expression is. It can be characteristics, it could be some examples. Then over on the right, I want you to create bubbles that refer to what an algebraic expression is. And then in the middle here, you are going to link and have one bubble that has a line going to each that is something that they share in common. So what is something that a numerical and an algebraic have together? That's what you're going to create in those bubbles. Okay, so do as many bubbles as you can think of related to numerical and algebraic expressions. When you're finished with that, you are going to create some single bubble maps. And we're going to create those using our 4 operations, addition, subtraction, multiplication, and division. So you're going to have 4 bubble maps, one for each operation. The first one you're going to do is addition. So I want you to think of words, and you can also use your internet to look up words that when you see in a problem you know refer to addition. An example of that is when I see something that says find the sum of, I know I'm going to be using addition. I'll do one more for you. If I see the words increased by, a certain amount increased by something. That means addition. So again, create lines and circles, bubbles, to explain all the words that you can think of that mean you're going to be doing addition in a problem. And then what I want you to do is do the exact same thing for subtraction, multiplication, and division. So you're going to end up with 4 bubble maps, 1 for each by the time you finish. As many as you can think of, and we'll discuss these tomorrow. But one thing I want to go over, so you can pause the video and do all of that and then press play and listen to this part I'm about to say. This is really important. I want to go over this part over subtraction real quick because this can be a little confusing and it's really important. So what we have here is we have x minus 12. There's a couple different ways we can say this. I can say or write this as the difference of x and 12. So that would be correct to write out. The difference of x and 12 is x minus 12. Okay, what if I want to use the word less than? So I just gave you one of the words that can be part of your bubble for subtraction. If I want to use the words less than, this is a really, really important concept that you understand. Less than is what we call a turnaround word. So when I see less than in a problem, it's backwards the way that you write it. So instead of saying x, what comes first is less than 12, you have to turn around the order. So instead, I'm going to write 12 less than whatever I started with. I started with x. See how those two things are backwards in order? So what came first here, I wrote after the word less than. What came after the subtraction sign got written before the words less than. That's the case anytime you see less than. You have to flip your order. So let's look at the example next to it. I have 9 decreased by 8. What does decreased by mean? That means subtraction. So I start with 9 and I decrease that by how much? By h. So 9 minus h. Then our last one here, h less than 9. There's that key word less than. So I do not write h minus 9 because that's keeping with the same order. When I see less than, I have to flip my order. So I have to put the 9 first, then subtraction, then h. We'll practice this some more, but I just wanted to make sure that that was clear. Last thing, and then we're done with this video, what it means to evaluate an expression. The word evaluate, it's a vocab word, means to find the value of. Okay, so I'm finding the value of an expression, c minus b. Well, it tells me in my directions that c is 2, so instead of writing a c, I'm going to write a 2 minus my b, which is 7. 2 minus 7 gives me negative 5. So I found the value of what c minus b was given the numbers up at the top. Now I'm going to find the value of, evaluate the expression a times c, or ac. A is negative 4, c is 2. Negative 4 times 2, when they're written right next to each other like that, that means to multiply. So I end up with negative a. So all that slide is showing you right there is what it means to evaluate, to find the value in, to plug in, to substitute a given value into variables. That's it. See you later, guys.